All right, in this first question on the WISER document, I want you to take a look at this part. It says, what is the molarity? Well, I wanted that to be yellow, but it turned out to be black. All right, so we are looking for molarity. I want you to take a look at your reference table. And on the very back of your reference table, let's see if we can zoom in, there is a section that says concentration right here. And let's take a point of concentration. And there's the formula for molarity. It's moles of solute, and you'll recall that the solute is the thing that's being dissolved, divided by liters of solution. Okay, so let's get that. I'm just going to put that on the side for now, and I'm going to write molarity equals moles over liters. I just shortened it a little bit. It's moles of solute over liters of solution. Let's see what else they gave us in the problem. Okay, they gave us 23 moles of sodium chloride. So the sodium chloride is the substance. We might need that, we might not. So some problems will use it, some problems won't. Divided by liters of solution. So then what I'm going to do is I'm going to take the molarity, which actually is abbreviated with a big M, and I'm going to take 23 moles and I'm going to divide it by 4.8 liters of solution. And then when I do the math, 23.0 divided by 4.8, I'm going to end up with 4.79166667. That's a big number. So we're going to take that, we're just going to round it to 4.8, big M, 4.8 molar solution. In this question, it's asking us for how many milliliters of water. So now milliliters is a unit of volume. Okay, in the formula, well, let's keep reading so you can see what else are given to us. So we've got 2.5 molar, that is not a highlighter, let's grab a highlighter, 2.5 molar. So that big M is telling me that I'm using a molarity formula. So again, I'm going to zoom in on this reference table so you can see, and the formula that we're going to be using is right here. Molarity equals moles over liters of solution. Let's get rid of that, put it on the side. So I'm going to go ahead and I'm going to write, I'll write in black, big M equals moles over liters. Okay, let's keep reading. They gave us 2.5, so they actually gave us this number right there. Okay, if 3.66 grams are used, now 3.66 grams is not, let's get a pointer, moles or liters, it's grams. But if you recall, moles and grams are interchangeable, and there's another formula on this reference table, let's go ahead and grab it again, that allows us to take moles, oh, come on, there you go, and we are able to change moles to grams and grams to moles. And it's right here, moles to grams. This is given mass as grams, and that's moles. So I'm going to go ahead and I'm going to take this formula, this one right here, and I am going to, ooh, got all connected like. Okay, I undid that. I don't know how that happened, but all right. I'm going to take, and we're going to take that formula, moles equals grams over gram formula mass. Okay, they gave us grams, so that's going to go right here, 3.66 grams over the gram formula mass is going to equal moles, and we need moles. That's what we need to put in over here. Okay, so this number and this number are the same thing. We have to find the gram formula mass. Well, they gave us calcium nitrate. Well, let's go ahead and write the formula for calcium nitrate. Calcium is Ca, nitrate is NO3. We're going to put our oxidation numbers in. We're going to cross them down So that 2 is going to come down here, 1 is going to go down there, and you're going to get CaNO3 2. Well, now that I have that, making it fairly small, I'm going to have to find the gram formula mass given that calcium nitrate. So we're going to take calcium. I just pulled up the periodic table. We're going to look at calcium. It's over here. So let's zoom in. And you see how this calcium is 40.08. We're going to just keep it as 40. So calcium's mass is 40. And we have 1 calcium, and it weighed 40. That's 40. We're going to look at the nitrate now, the N, right here. How many of them are there? There are 2 N's, because there's 2 NO3s. So there's 2 N's. Each one weighs 14. That gives me 28. And if you don't know where I got that from, again, go right back to your reference table, and N is going to be 14. Oops, I need a pointer right there. That's where I got it from. Okay. Stuck that back on the side, and then we're going to do the O. And how many O's are there? There are 6 O's, and each one weighs 16. So that's 96. And we're going to add all of those guys together. That gives us 164 grams per mole. That number, let's get a highlighter here. That number is this number right here. Because remember, we are looking for moles. We were given grams. Grams are right here. So these two are the same. I'll make it nice and yellow for you. Okay? So I'm going to go ahead and I'm going to plug all those numbers in, and I'm going to end up with 3.66 that's grams, divided by 164 grams per mole equals 0.022 moles of CaNO3 Alright, so now let's keep going. I'm gonna rewrite it down here at the bottom. I made myself some more room. So I'm gonna take this formula, molarity equals moles over liters. Which one are we looking for? We are looking for milliliters. So we're going to find liters and then eventually convert it to milliliters. We have moles, voila, there it is, 0.022 moles, and they gave us 2.5 molar. So we have this number, and we have this number, now we can find this number. So let me go ahead and plug those in. If I can find a pen, that will actually look good. All right, let's take this red one. 0.022 moles over X is my liters is going to equal 2.50 molar. And then we're going to do some fancy math, right? We're going to cross multiply. So we're going to get 2.50x equals 0.022 times 1. I don't have to write the 1 in for you. And then x is going to equal 0.0088 liters. Remember, we're looking for liters in this formula. So now the question is asking us about milliliters. To go from liters to milliliters, let's see, this is really giving me a hard time trying to move things around so you can fit it all on there. Okay, so to go from liters to milliliters, we're going to move that bad decimal, that bad boy right there. We're going to move it 3 places to the right. Okay, and we're going to get 8.8 milliliters. Now in the question, I asked you to go to the nearest tenth. 0.8 is the nearest tenth, and we're good to go. Alright, let's try another one. Alright, I know this is not the perfect video, but hey, it's getting the idea across. Alright, so in this question, we are looking for mass. It says, what mass of silver hydroxide? Well, mass is always grams. Woo, not what I wanted. Okay, so we're looking for grams. Silver hydroxide, I'm just going to write the formula. Silver is Ag, hydroxide is OH. We'll write the oxidation numbers in. We'll cross them down. We get AgOH. Must be used to prepare 0.5 liters of a 0.6 molar. This capital M is the big clue. we know we have to use a formula that has molarity in it, which is big M. So I only know one so far. It's molarity equals moles over liters. They gave us moles. They gave us liters. Let's see, they gave us liters right there, 0.5 liters. So that's going to go there. Let's get a pen. 0.5 liters. They did not give us moles, so that's going to be my X. And they gave us big M is 0.6. So I'll go ahead and I'll write that in. 0.6 big M. Then through the magic of TV, I'm going to do the X equals 0.3 moles. Remember, this X is in moles, so it's moles over liters, so that has to be moles. Now we have moles. I want to know grams, and if you remember from the last problem, moles and grams are interchangeable, so we're going to use the formula moles equals grams over gram formula mass. Get that on reference table T. We know moles, which is 0.3 moles. That number I got from there, and I'm plugging it in right here, equals grams over gram formula mass. Now, we don't have gram formula mass, but I did figure out what the formula was. So we're going to go ahead and we're going to figure out the gram formula mass. Let's do that over here. Let's do gram formula mass of AgOH. So we're going to look up Ag. There's one of them. It's 108. Remember, I get that right from my periodic table. That's 108. We're going to have O. There's one of them at 16. And we're going to have H. There's one of them at 1. That gives me 125 grams per mole. That number right here is going to go down here, okay, because it's going to be grams formula mass. So let's go ahead, put it back to a red pen. We'll put 125 grams per mole. We have to solve for X. We got 37.5 grams. Now, look, it asked us for grams. It asked us for mass, so we're good to go. So the only thing else we have to be really careful about is I asked you for a whole number answer. 37.5 is not a whole number, so we rounded to 38 grams of AgOH. That should have been your answer. Okay, let's try another one. Okay, this question's a little bit different because we're going to use a different formula for this one. Let's read it so we know what it is. Let's get a pointer so you can see what I'm looking at. How much of 8 molar stock solution? Stock solution is the stuff I take out of the cabinet. And this is telling me that it has a concentration of 8 molar. So how much of this stuff am I going to be required to prepare 100 milliliters of a 2.5 molar solution? So we're going from 8 molar to 2.5. It is being diluted. Diluted meaning that it is less concentrated than when we started. So in this case, if I'm doing a dilution, I have to use the formula MAVA equals MBVB. And we're getting this again from reference table T. Let me show you where that is. Okay, so that's right here. Let's get a pointer. Oops, what's going on? Hit the wrong button. All right, MAVA equals MBVB. Okay, in this question, you're always going to have 2 molarities and 2 volumes. So there's 4 variables here. 3 of them are going to be given to you. 1 of them is what you're going to be looking for. So let's shrink this down, put it on the side here. Okay, and let's look and see what they gave us. They gave us 8 molar stock solution. Oh, how did I do that? Let's see. 8 molar stock solution. That's one of the M's. And they gave us 100 milliliters. That's a volume. So it's either VA or VB. And a 2.5 molar. Now here's a hint. When you have 2 numbers and they are attached with an of, those 2 numbers are going to go on one side of the equation. So these 2 numbers, 100 milliliters of a 2.5 molar, are going to be on one side of the equation. I'm going to pick the right side. You could just as easily pick the left side. So molarity is going to be 2.5. So I write it under the M. And the volume is going to be 100 milliliters. Now let's do the other side. 8 molar. So that's going to be this M right here. I'm just moving it over so I have some room. Okay? And we are looking for volume. How much? That's a volume. So now we've got 8x equals 250. X is going to equal 31.25 milliliters. If this, let's see, is this a highlighter? If this is in milliliters, then this volume is going to be in milliliters. Just like this was in molarity and this is in molarity. See? Big M, big M. The units on this in this equation must match. So they didn't ask you for milliliters or liters. They just said how much. So I would leave it in milliliters. But I did ask you to answer in a whole number. So the whole number answer for this is going to be 31 milliliters. Okay, let's try one more. All right, in this question, it's asking us what is the molarity. So I know now I've been introduced to two formulas. I'm going to write them both down. Molarity equals moles over liters, or MAVA equals MBVB. Let's see which one I'm going to use. This has a keyword. Whoops, that's not a highlighter. Let's see, is that a highlighter? That's the eraser. All right, and this word is dilute. We're diluting. So what will the molarity of a dilute solution of potassium carbonate be if 55 milliliters of 10.5? Now look in the last question, I told you that little clue. If they're two numbers and they're connected with an of, they're going to go on one side of the equation. So which equation do you think we're going to use? Right, this one. So I'm going to go ahead and I'm going to erase this one because we don't need it. Okay, let's just do this. Concentrated 55 milliliters of a 10.5 molar concentrated solution are used to prepare 250.00 milliliters of a dilute solution. If you see the words dilute, neutralize, titrate, usually you're going to, well, absolutely you're going to use this formula. So now we know that these two numbers go on one side of the equation. So let's pick the left side this time. It doesn't matter which side you put them on. I got 10.5 molar times 55 milliliters equals 250 milliliters. So X is my big M, 250.00 milliliters. And then we're going to do some fancy math. And you end up with 2.31. What are the units? Big M. Okay. Now look here, round to the nearest tenth. So we're going to go X is equal to 2.3 molar solution. All right, last question. You are trying to determine the concentration of a stock solution. Remember, stock solutions are the things that are coming out of the stock cabinet of hydrochloric acid. So you're looking for concentration. Now, concentration is measured in capital M. Molarity. That's not a pen. Molarity.